Hello everyone, welcome to the day 7 material. So I was able to get most people's questions answered about the previous days, but if you're still having questions, please send me an email. When you do, it will be helpful if you send me a picture of the following stuff from your calculator. It'll be helpful if you send me a picture of whatever their error message is on your main screen. If you can also send me what you're doing here. And then finally, if you come in over here and you look at your data, what does your data look like? Because sometimes the problem's those. Also, if you could possibly send me a picture of the window, that will help as well. Okay, so moving on to today's stuff. Today we're talking about the normal distribution. Now, hopefully once we start getting into this, you'll have some memory of what you did last year because the stuff is very similar. So a normal distribution, that's sometimes called a bell curve. Okay, and it occurs in a lot of situations. You have personally experienced it when you took an SAT, a PSAT, when you're in grad school, when you take the GRE. So most standardized tests are normalized. Every single one of you took the ITBS at some point, and when you took the ITBS, that's that Iowa test of basic skills, that was normalized. Okay, so when you're looking at a normal type environment, the bulk of people will sit in the middle of your distribution. They're average. That's called a C average kind of person. A small number of students, a little bit smaller, will score a B or a D, and an even smaller percentage is going to get the F or the A. So think about that as the F or the A is way out here if you're in a normal distribution. Bell curves are perfectly symmetrical, and the total area under this curve, if I add up all the probabilities, is supposed to be 100% or 1. Okay, so what kind of things show up as being normally distributed? The heights of people, blood pressure, points on a test could be if you are taking a standardized test, IQ scores, sometimes salaries, a lot of different things are. Now there's two main components that you will have to be able to tell me about a normal distribution. What's the center? That's the mean. It has a Greek letter mu. It's right here, Greek letter mu. When we're calculating it with our calculator, we will sometimes use X bar in the calculator. Okay. Some of the online programs correctly use the mu instead. And you'll need to tell me what one standard deviation is. That is the Greek letter sigma. Now that is on our calculator. That looks like sigma x. All right. Now there is a formula for the normal curve, but that requires you to be able to do calculus. So we do not use that formula. Instead, we're going to use our calculator, which does much of the same stuff. So normal distribution is typically written with a capital N, followed by the mean, followed by the standard deviation. So to read that notation, you say X is a random variable with distribution, normal, with a mean of 1 or a mean and a standard deviation, okay? So the distribution follows the following pattern. It's called the empirical rule. Now, in addition to being able to calculate things with our calculator, we will practice using empirical rule. Empirical rule is not as exact as your calculator, but it is pretty good. So first thing is 68% of data will fall between 1 and 2 standard deviations. So if you look down here, notice that 34 plus 34 is 68, so that's about that amount of distribution. Next, 95 falls within 2 standard deviations. So if I go out 2 to the left and 2 to the right, and I add that up, that gets really close to 95%. Okay, the last one says that 99.7% of all the data will fall within 3 sigmas. So if you go from here to here and you add up all the probability, that's the 2.1, the 13.6, the 13.4, sorry, 34, 34, 13.6, and 2.1, you're going to be really close to 99.7% of the data. The only thing that's left is this tiny little bit in the tails. And if I add that tiny little bit in the tails in, I should be really close to 100%, if not exactly 100%. Okay, so properties of the normal distribution. Because it is perfectly symmetric, the mean, the median, and the mode are all equal. So the mean is here, the median is here, and the highest possible value is also here. The curve is symmetric. So if you didn't draw it symmetric, that's on you because it's symmetric. Exactly half of all the values are to the left. So if I add up all the probabilities on this side, I should get 50. If I add on this side, also 50. So exactly half are to the left of the center and exactly half are to the right. And if I add up all the probabilities, I should get 1. Okay, so hopefully that all makes sense and seems somewhat familiar with what you did previous years. So let's take a little bit more of a detailed look and then we'll try some examples out. All right, so one way to figure out how data are distributed is to plot them. Okay, so we have done that over the last few days doing some plotting. If you have not done that, please go back and practice the plots. Now, to help us examine the distribution, we standardize it. So what you want to think about standardizing as is putting everything into the same units of measure. So it'd be like if you had somebody walk over and they were doing empirical units, so that's inches, feet, and you had someone walk over who was doing metric units, and you're like, I need to get these into one single unit of measure. That's what standardizing is. That's what a z-score is. Please make sure you learn this formula. Remember that we have seen it before, but using the x bar instead of mu, sometimes that's used interchangeably. Now, what we're doing with z-scores is we're going to be converting everything and standardizing it so that we can see how the distribution really looks. Now, when we standardize it, if you're looking at a z-score table, which we will at some point, the area that's always given is assumed to be the area to the left, now, of whatever the z-score is. Now, the nice thing is our calculator will do either side, and we'll practice that, but you don't have to have a calculator. So the process of calculating is state the problem. So what are you trying to find? Next, draw a distribution and shade it. Standardize your calculation. In other words, get your z-score, then you use your z-table or technology, and then at the end, tell people what you actually calculated. So let's take a look at 3 example problems. Okay, first thing, the level of cholesterol in the blood is important because high cholesterol levels may increase the risk of heart disease. The distribution of blood cholesterol levels in the larger population of people of the same age and sex is roughly normal. For a 14-year-old boy, the mean is 170, and the standard deviation is 30, okay? What percentage of boys have cholesterol more than 240? So we're looking for the probability, capital P, that our random variable x is greater than 240. Okay, so let's start by drawing our picture out. So I have already made the little curve for you. You just need to label it. So we know what our mean is. Our mean is 170. Okay, now to mark this point right here, you're going to take 170 and you're going to add 30. To mark this point right here, you're going to take 170 and you're going to add 30. Well, you're going to take 170 and add 60 because it's 2 standard deviations. So 200 plus 30. And then to mark the last one, again, you're going to add another 30. Now, what if I want to go the other way? Since I added to go this way, I'm going to subtract to go the other way. So 170 minus 30, 140. 110, and then finally 80. Now my problem says greater than 240. So if I'm looking at my picture, I'm guessing 240 is about here. So that's the area I want. It's that one right there. That's what I want. So I've now done my drawing. Now let's standardize. So when I standardize, I will take a Z and I will say Z is greater than 240 minus 170 over 30. So that's that x minus mu over sigma. So that means that Z is greater than 2.333. Okay, so let's take a look at our calculator and see how we're going to get that, since we might not have a normal curve at home. Okay, so first thing I'm going to do is I'm going to go over to my Distre menu. Distre is right up there, D-I-S-T-R-E. It's right above VARs. Now there are two options for normal. Please only use CDF. If you use PDF, the answers are not right. Okay, so if you have the newer version of the calculator, don't worry folks who have the older version of the calculator, I'm going to show you how to type it in too. Not a big deal. It's going to ask you to enter some information. So let's go to our picture to figure out what our answers are. So the lowest value that we're looking at is 240. Our upper value, now I don't know where this curve ends, so you just put in a really big number, like maybe 1,000,000. See, tons of zeros. I don't know how many I just put in there, but it's a lot. Then you're going to put in the mean, and you're going to finally put in your standard deviation of 30. Now then you're going to say paste. Oh geez, I put it in the wrong spot. So let me try that again. Distre, CDF. Would be nice if I was on my home screen. Okay, now at this point you're going to press enter and it's going to tell you what the probability is. So your probability is 0.0098 or 0.98%. Okay, that is less than 1%, which means it is not going to happen. So I would say that the probability a randomly chosen "14-year-old boy has cholesterol above 240 is 1%. In other words, it's not going to happen. Okay, so I promised I would show you all how to do this if you have an older version of the calculator. So if you have an older version of the calculator, and I'm sorry I don't have one available, you are still going to go to VARs, then Distre, then normal CDF. Now the problem is it's not going to give you that nice menu. So instead, what you're going to type in is it's going to put up norm CDF on your home screen. It will open a parentheses. So that's what it'll look like for you. So what you're going to do is you are going to type in the exact same stuff that we typed in. You're going to type in 240, then you're going to put a comma. The comma is right above the number 7. Okay? Then you're going to type in some really huge number. Make it big, really big, huge. Then you're going to put another comma right above the number 7. You're going to type in your mean, which in this case was 170. Put another comma, and then you're going to type 30 and close your parentheses, and that will give you the exact same answer. Okay, so vars, distra, normal CDF, it's going to pop this up on your home screen, and then you are going to type in the stuff using the comma. So not too bad. It's a little different, but not tremendously different. Okay, now what if you've calculated the z-score and you'd rather use the z-score? Oh, wow, that is no problem. So I will go to distra again. And instead of using upper and lower bounds the way I'm doing here, I'm going to use 240 was converted over to 2.333. I'm going to keep that massive number I have here, but if you want to use the standardized scores, you'll need to use a mean of 0 and a standard deviation of 1. Oh no, look, it's almost the same answer. Matter of fact, it's close enough to the same answer that when I look at it, the only place it changes is right after I put in the 1 and the 5. Now, the reason I'm getting a slightly different answer is that the 2.333 was rounded. So this answer is more correct than this one. But if you notice, it's close enough where we would get the same answer either way, less than 1%. Okay. So let's go down to our second one. So use the information above. Now we want the probability that our 14-year-old boy has cholesterol above 175. Okay, so remember, go back here and relabel. Okay, 140, 110, 80. All right, so now we want below 175. So 175 is about there. What if you're not perfect on that? It's okay. So we want all of this area. Now the last time we had a teeny tiny little area, like it was so small, and you looked at it and you went, that is not a lot of space. As it turns out, that made perfect sense. It was about 1%. In this case, since that's over halfway, I expect a number bigger than 50. All right, so I want the probability that my random variable x is less than 175. Okay, so first let's standardize. So z is less than 175 minus 170 over 30. Okay, so again, I'm going to reach for my calculator. 175 minus 170 divided by 30. So I get z is less than 0.1667. I mean, you can go as many decimal places as you want. And now I'm going to use my calculator. So I'm going to go back to the distro menu, pick CDF, not PDF. So my lower value this time is going to be like a really low negative number. So negative 1,000,000,000,000. So I made it huge. My upper value is 175. My mean in this case is going to be 170, and my standard deviation is 30. Paste. Oh, look at that. My probability that I created was 0.5662 or 56.62%, which makes perfect sense with my picture because that's a little over half of the problem. So my conclusion is the probability a randomly chosen 14-year-old boy has cholesterol below 175 is 56.62%. So in other words, that's pretty likely. Okay, our last one says find the probability between two values. So that's capital P for probability. Now you're always going to write your smaller number first, so 170 is less than X is less than 240. All right, now in order to do this one, I would have to do two separate z-score calculations. So first thing I have to do is 170 minus 170 over 30 is less than z is less than 240 minus 170 over 30. Okay, so if I'm doing that, I will have 0 is less than z. Now remember, I already did this calculation up here, so I'm just going to transfer it down. 2.333. Okay, so now let's go draw our picture. So picture, you got 170, 200, 230, 260, 140, 110, and 80. So if I'm doing this one, I know that I want between 170 and 240. Okay, so this is a much bigger area than the first problem, but it's smaller than the last one. So I know that my answer has to be somewhere between 50% and 1%. Okay, so that's the area that I'll be calculating. So go into your calculator, go back to Distra, pick a normal CDF. Now this time I am going to be going from 170 to 240. Okay, so 170 to 240. So I want this side to this side. That's my upper and my lower. My mean and standard deviation stay the same. Look at that, about 49%. Very logical. So that is 0.4, let me switch to something that's easier, 0.4902 or 49.02%. So if I'm writing this out, I'm going to say the probability a randomly chosen 14-year-old boy has cholesterol between 170 and 240 is 49.02%. And that's how you work all these problems. So if you look on the next section of stuff, these will be your z-score practice problems. See, z-score practice, day 7. And there are all these distributions for you to practice with. See, look, all of those distributions. So give them a try. Again, if you have questions, just make sure you tell me that it's practice day 7 and tell me what the problem number is so I can help you out more quickly. I hope you all have a really wonderful day. Sorry everybody's stuck at home, but remember you can always leave your house and go out for a walk. Have fun.